Myself and another shooter will be demonstrating the shot finding capabilities of the Shotpoint system by being the evil snipers.
So you're shooting live rounds today?
We will be shooting live rounds in various calibers, 223, 308 NATO, 7.62 by 39 like the AK-47 fires.
Okay, Pete, can you fire 3 shots in succession?
Yeah, they're not going to be fast, but I'll fire.
Okay, all right.
I'll fire 3 shots. That's easy. We all set?
All set?
Yep. Somewhere here. Up there.
So everyone kind of says that they think that it's definitely over here on the left side. Now, if you happen to be, you know, maybe in an urban area, so we have only 1 bounce off of here. But if there was a building in between you and exactly where that shooter was, you would be only hearing that. So that makes it, the compound's the problem. But right now, as it is, you think maybe he's to the left side. That's about as good as we can get. Can anyone find him for that information? No. Okay, so thank you, Pete. Would you like to stand up and show us where you are? We all know he's on the left side.
You see him waving.
You see him waving.
Barely see his own.
In the interest of time, we are going to focus on a couple of specific instances that showcase the accuracy and real-world scenarios that make Shotpoint the best gunshot detection solution in the industry. First, let's explain how the Shotpoint system reports data. As shown, this first shot that occurred on Thursday morning was the overhead shot. This occurred when we had visitors that were in the bottom floor of the quarry standing near the sensor field as depicted earlier in this video. The green dots on screen are the sensors, and as they flash, they are reporting healthy heartbeats. Each sensor refreshes every few seconds, indicating that the sensors are connected to the network and reporting. We should note, for this demo, all of the sensors are set up on the same plane. Ideally, Shotpoint sensors would be set up in a 3D environment, meaning multiple levels or elevation, which would allow for even greater precision. The red line is the trajectory. The trajectory is a proprietary tool in Shotpoint that is used when we do not detect a muzzle blast. This is most prevalent when a silencer is used, and, as you can see, Shotpoint is still capable of identifying trajectory. In the event Shotpoint is able to detect a muzzle blast, we can gather valuable position information in addition to trajectory. With trajectory, we have a useful tool, represented by this blue arrow. As you move along the line, the blue arrow reports elevation and can tell us which floor is represented. Of course, the intent of this proprietary tool is to identify active shooters in an urban environment. This quarry has walls as tall as 500 feet, allowing us to mimic city settings or dense urban areas like Las Vegas or New York City. We can move along the trajectory line until we reach a structure, like a wall or a building. In this case, the trajectory intersects with a point on the map, allowing you to see the line of elevation. By clicking the trajectory line at the point of intersection, we see that the elevation line is negative 461 feet, or underground. This tells us immediately that the shooter is on the other side of the quarry. As you can see, the first shot was taken and shot away from the sensor field. This trajectory is at least 100 meters missed distance from the sensors, and Shotpoint is still picking up and estimating a trajectory position even with the ambiguity. The first actual shot was shown here, on a slightly elevated road about 30 feet or 3rd to 4th floor. We know this was Pete because he was using a rifle with a silencer, which means we did not get a muzzle blast. This real-life scenario is becoming more and more popular and more likely that security will encounter active shooters with a silencer. In these instances, Shotpoint's ability to track a trajectory is invaluable, allowing first responders to identify the position of the shooter. Now, the second shooter is shooting a 308 without a silencer. In this case, Shotpoint can correctly identify shooter elevation. If we click on the elevation indicator tool, you will find two pieces of valuable information. You will get the elevation at the point along the line, but because we know the actual shooter position, we also get the shooter elevation and the computed location shown by the red dot. This shooter is approximately 57 feet, or the 5th and 6th floor, which is accurate because we know he was shooting along the road traveling upward at the quarry. To test the accuracy and reliability of Shotpoint, Pete and Mike took turns shooting alternate shots in succession. As we zoom in on the timeline, you will see that the spacing of the shots is approximately 2 to 3 seconds. We have Pete represented with trajectory-only information because of the silencer, and Mike represented by the localization marker because of the muzzle blast. You see this represented as we click the various dots in the Shotpoint report. Most impressive is Shotpoint's consistent trajectory estimation from shot to shot. Later in the demo, Pete and Mike moved to hidden, higher elevation areas to mimic more recent urban active shooter scenarios. As you can see, Shotpoint accurately identifies trajectory from both shooters. As shown earlier, Mike was not shooting with a silencer, but the distance of the shot and the distance from the sensors removes the ability to use muzzle blast as an accurate shot detection tool. However, Shotpoint picks up the shot and is able to provide accurate trajectory information within 4 seconds of the shot. What we see here is Mike at 500 feet, or the 42nd floor. Pete at 463 feet, or 39th to 40th floor. Mike again at 450 feet, or approximately 38th to 39th floor. And again, Pete moving at 485 feet, or approximately the 31st floor. For more information about Databuoy or the Shotpoint system, please visit our website at www.databuoy.us.